Please note, in example 2, we are dealing with an isosceles triangle. This is not a right triangle. You cannot just go to Pythagorean theorem. However, this unit is based in right triangles. If we draw in the altitude of the triangle, which creates a right triangle, that altitude takes the 30 degrees 30 minutes and splits it in half. It acts as a bisector. We then need to find y. Notice in the relationship between y, 7 and 15 degrees 15 minutes is going to be using sine. We write an equation. We solve the equation for y. Remember, y is only the bottom of the right triangle. We were asked to solve for the entire base of the isosceles triangle. So we need to do a quick calculation, multiply that number by 2, and we find the base is 3.68. Don't forget your units. 3.68 should include the word inches. Take a moment to read example 3. Feel free to pause the video at any time if you need to. A majority of the questions will be word problems. You will need to read through the information, draw a diagram, label sides, write equations, solve including units. The hot air balloon is released and flies vertically to a given height, which they are labeling with letter H. The crew drives 1.2 miles along a level road and looks back up at the balloon, creating an angle of 30 degrees. You are asked to find the height. If we try to relate h, 1.2, and 30, we can do so using tangent. Please note, the h, which represents the height of the balloon, is the opposite side to the 30 degrees, not h of the hypotenuse. The height of the balloon is 0.69 miles. Don't forget to include your units. The next part of the notes deal with new definitions of angles of elevation and angles of depression. Notice in the drawing, the observer, who is the person, is at ground level. She is looking up at an airplane. By raising her eyes up, she creates an angle of elevation. The subject, which is the observer looking at the plane, is in the bottom left, looking up. This is called the angle of elevation. The angle of depression would be from a subject of the plane, or pilot in this case, looking down, dropping his or her eyesight down to the observer. Okay? It's very important to distinguish between the angle of depression or elevation based on where the subject of the problem is located. The angle of depression is the same measure as the angle of elevation. What? How can this be? Well, if you look at the last example, we have the airplane, which was up at the gold square, and we had the observer, who was at the round circle. If those line of sights are level, they create parallel lines, cut by a transversal. Notice alternate interior angles from geometry class. The angle of depression is the same as the angle of elevation. Please add the following to your notes. The angle of depression is based on where the subject is drawn. The angle of elevation is also based where the subject is drawn. If I add in a perpendicular from the location of the plane to form a right triangle, that angle at the top is never, ever, ever going to be the angle of depression. The angle of depression would be outside of the triangle in this case. At this point, I'm going to ask you to stop the video. You should have received an application worksheet. There are 6 problems on the worksheet. You are to use your notes to complete them. Please show this worksheet to the teacher when you are finished. For each problem, there should be a diagram labeled, a trig equation, and the correct units.